right, good Monday morning to all, or afternoon, depending on when you're in this class, period 1 or 6. It is February 14. Happy Valentine's Day. This is Mrs. Conway. Sorry I could not be with you today, but I am attending a meeting today. Today we are going to be looking at some more radical functions and graphing them, and also looking at giving the domain and range of each of them. You have an activator today, as usual. We are going to also be checking the homework and then going through the video with some practice. Your homework tonight is to finish the Graphing Radicals packet that you start in class, and we will be checking that, and it is due tomorrow. So if you want to go ahead and pause the video for a couple of seconds so that you can complete your warm-up, go ahead and do that now. Alright, so let's go ahead and go over the activator. Using that radical function form that we talked about on Friday, if a is 1, n is 2, h is 4, and k is 3, what equation are we going to have? That equation is going to be y equals, since n is 2 and a is 1, I could write a 1 here, but I really don't have to. I can go right into the square root, and again, since n is 2, I could put a 2 here, but again, it's assumed that this is the square root just from the radical symbol. So then we do x minus h, which is 4, and then plus k. So with that equation, we know that from our discussion on Friday that h moves the equation left and right, and k moves our equation up and down. So this graph would be moved 4 units to the right and 3 units up. And again, you could see that by going to your calculator, and if you want to go ahead and put in that equation into your calculator, you would do the square root of x minus 4 plus 3. When you press graph, you can see that this graph is moved 4 units to the right and 3 units up. Okay, so let's go move on to check your homework. Here's your homework from the weekend. Number 2 and 3, we're looking at finding the error in the problems. 15 through 18, again talking about transformations. We talked about transformations on Friday, and again for warm-up today. So you can see the answers for those for 15 through 18. Numbers 19, 20, and 21 were matching, so those are the appropriate graphs. And 22 through 24, you did actually have to graph those problems. It also lists the domain and range are at the bottom, which we're going to be talking more about today. So if you want to pause this for a couple of minutes to go ahead and check your homework, we will then move on with the lesson. Alright, so let's go ahead and move on. The worksheet that you're getting today is on graphing radical functions. We talked about the form, yes, on Friday, and then for warm-up today. So in part 1, we are just going to graph these radical functions. We do need to make sure that we identify at least 3 points on each of the graph and find the domain and range. Excuse me. On numbers 3 and 4, we're actually going to describe the effects, which again, describing the effects is transformation on the graphs as well. So for number 1, this is our very most basic function of the square root of x. So going to your graphing calculator, you can put in the square root of x and then press graph. Okay? You can therefore see what happens to the graph when you have the values of x. And if you go to your table of your calculator, which is second graph, you can see that the perfect squares are the ones that have integer values, which they are actually the easiest ones to use. So you can go ahead when x is 0, the square root of 0 is 0. When x is 1, the square root of 1 is 1. When x is 4, the square root of 4 is 2. And when x is 9, the square root of 9 is 3. We have actually identified 4 points, which is fine. The 9 we might not get to, so we'll see. So there's 0, 0, 1, 1, 4, 2. And as you can see, 9 does go off the graph, so we're just going to stick with those 3 points. And so this would be your graph of the square root of x. The domain of this graph are all of the values that x can take. So we're going to look up and down the graph, and if you look up and down the graph, you can see that you don't reach x values until you get to here, which is at x is 0. And then this function does keep increasing. It is a slow increase, but it does keep increasing the further that you go. So our domain is actually everything from 0 to positive infinity. Those are all of the values that x can take. Okay? Looking at the values that y can take, again, in this case, the range is the same thing, everything from 0 to infinity, because it does keep increasing. Notice we have no negative values for each, and both the domain and range start at infinity. For number 2, we're looking at the cube root of x. So going back to our calculator and going back to y equals, we do have to clear that out, and we have to select from the math menu the cube root function, which is option number 4. And we're doing the cube root of x. If you go ahead and press graph, you can see how that cube root function behaves. And in order to graph this on our coordinate plane, we do want to identify 3 points. So if you press second graph, you'll be able to see our different values. And if you notice right here are the most accurate values. We don't get another cube root value until we get to -8, which is probably, yeah, it will go off of our graph. So we do just pretty much want to take those couple of values here right at -1, 0, and 1. So if you can see at -1, at -1, 1 is where the graph is. So we are going to plot that when x and y, when x is -1, y is -1. When x is 0, y is 0, and when x is 1, y is 1. So we're going to go ahead and plot those 3 points on our graph. And from the way that the graph looks, you can see that the graph does look like that. So you are now going to sketch that graph. It's going to look something like this. And domain, in this case, looking from left to right, is all real numbers. So from -infinity to infinity. And the range, looking up and down the graph, again, that's going to keep going up and that's going to keep going down, so is as well from -infinity to infinity. Alright, let's go ahead and move on to number 3 and 4. And I'd actually like you to go ahead and try number 3 and 4. And this one you don't have to identify the domain or range, but you do have to identify the effect of A. And the effect of A is a transformation. But again, A is not looking at moving left and right. We did talk about what that number had an effect on when we did these on Friday. So you go ahead and try it, and if you can go ahead and describe the effect of A. Go ahead and pause the video. Alright, so if you're looking at y equals 3 times the square root of x, that is not the cube root of x, so 3 times the square root of x, and graph, you can see that the graph kind of increases at a little bit quicker rate. If we take a look at the values of that graph, we have errors, of course, with the negatives, but now instead of 0, 1, 1, we have 1, 3, which looks like it kind of corresponds to that A value. And that is what we call a growth rate. So 0, 0, 1, 3, 4, 6 are the points that we're going to graph. On our coordinate plane. So 0, 0, 1, 3, and 4, 6 are the numbers we're graphing. It's going to keep increasing as well. So it appears as the effect of A is having an effect on the rate of growth. It's the rate of growth. So the effect of A here will also have that effect on A, which is the rate of growth. So in this case, it's a -2 times the cube root of x. So let's go ahead and plug that in our calculator. We're going to go to y equals, and we're going to put in -2, and go to our math key for the cube root, and it is the cube root of x. Go ahead and press graph, and you can see that that kind of switches the graph around from the way that we originally were looking at it. So the effect of A, it looks like that negative flips it, and the 2 makes it grow at a little bit quicker rate. So what we're going to do is go to your second graph key, and you can see the table of values where you have, again, at negative 1, 2, 0, 0, and 1, 2. So we're going to go ahead and make those values. Negative 1, 2, still at 0, 0, but for 1, negative 2. So let's go ahead and graph those. So 0, 0, negative 1, 2, and 1, negative 2. And remember that the graph looks something like this on either side. So again, the effect of A affects the rate of increase and decrease. And it also, the negative, flips the graph. Okay. So let's move on. In part 2, you want to graph the radical functions and then identify h and k. We talked about this on Friday. And then you want to shift the graph h units horizontally and k units vertically, and then describe the transformation for each. Alright, so here's your answers for numbers 5 and 6. Again, for number 5, it moves the graph 3 units to the left, and for number 6, it moves the graph 2 units up. Okay, so let's move on to numbers 7 and 8. Number 7 and 8, again, you're going to do the same thing, so go ahead and do that now. So for number 7, the graph is moved over 3 units and down 1, and it dilates the graph by a factor of 2. For number 8, the graph is moved right 5 units and down 4, and dilates the graph by a factor of negative 3. Moving on to number 9 and 10. Again, you want to do the same thing with numbers 9 and 10. Alright, so for number 9, the graph is dilated by a factor of negative 3. Where the graph starts is at negative 2, negative 1, which is your h and k. Moves left 2 units and down 1 unit. So this is what your graph will look like.